Hi, my fellow scientists, welcome to my study in which we focus on physics, particularly the physics for high school students. And we are currently on the topic of pressure. Pressure is a very important topic for the students in high school and also for those who are going to pursue physics in higher levels. So our today's focus is on measurement of pressure. There are various apparatus which can be used to determine the pressure of a substance, particularly when we are dealing with the fluid, that is liquid and gases. Today we want to look at a YouTube manometer, and we begin by defining what a YouTube manometer is. A manometer is an instrument that can be used to measure fluid pressure, and it consists of a tube filled with water or any other suitable liquid, as it can be seen in the figure below. In that figure, one of the lip of the manometer is connected to the gas supply, and when it is connected, the other side of the lip, the level of water will rise as indicated there. So using that setup, we are going to see how we can determine the pressure of gas in that particular YouTube manometer. Now, suppose one lip of the manometer is connected to gas supply. Due to pressure of gas, the water level in the other lip rises to a position, say, Y. This difference in water level is the difference between gas pressure Pg and atmospheric pressure Pa. Since X and Z are at the same horizontal level, pressure at X equals pressure at Z. Pressure at X is pressure of gas Pg. Pressure at Z is equal to the atmospheric pressure plus pressure due to the column of water. Therefore, pressure Pg is equal to Pa plus H rho G, where Pg is the pressure of the gas which is connected to the tube, and the Pa is the atmospheric pressure at that particular place. H is the height of the liquid column, rho is the density of water, and the G is the gravitational strength. So since density of water, rho, and the G are unknown, we can determine the pressure of gas if the atmospheric pressure is known at that particular place. Height is measured and its value recorded using a meter rule. We now consider an example on how we can determine the pressure of a gas using a YouTube manometer. This example shows us how we can numerically get the value of the gas connected to the YouTube, whereby the height H is measured using a meter rule, the density of water is known, and the pressure at that particular place is also known. Suppose we have determined the height as 20.0 centimeter and the pressure of atmosphere at that particular place is 103,000 Newton per cubic meter. Then the density of water, taking it as 1000 kilogram per cubic meter, pressure of the gas is equal to atmospheric pressure plus pressure due to the liquid column, which is given by height times density times G. Then substituting in the formula, pressure of the atmosphere is 103,000 plus 0.2, whereby 0.2 it is the height of 20 centimeter, which has been converted into meter by dividing by 100 times 1000 times 10. Then simplifying, we get 103,000 plus 2000 to get total of 105,000 Newton per square meter, whereby Newton per square meter is the SI unit of pressure. So learners, I want to give you an exercise whereby now take the height as 40.0 centimeter, pressure of atmosphere at that particular point as 100,000 Newton per square meter, and the density of water as 1,000 kilogram per cubic meter, and they also take G as 10 Newton per kilogram to determine the pressure of gas at that particular point. Thanks for watching. Kindly like, subscribe, and share with other learners so that we can continue learning together. You can reach out to my YouTube channel by using the name Luke Aaron 1. The spelling is as indicated so that we can continue learning together. Particularly, we are going to be concentrating on the key areas which are tested in KCSE and which also learners require as a prerequisite for further learning for those who are interested in learning physics at higher levels.